recording. Now we got some stuff that we can do. So jump back into wherever you were taking those notes the first time. And if you've got enough space, you can even jump back into where we got to with property number 6. If you have some space to just kind of fill in some examples along the way, great. If you don't, if you feel like you're kind of crunched for space and you want to just write it separately, that's cool too. So we'll keep it short and sweet, and then we'll actually get a chance to practice some stuff on Monday. And this is just tentative; things can change. But what I'm thinking is that we won't need all of Monday to practice this. We'll probably get to the point where we can start the first of 2 quizzes. Notes, of course, you can use if you want. All properties of exponents, kind of all of them 1 through 6. Right, 5 was anything to the 0 powers 1. 6 will be this one that we talked about. We'll have part of Monday and then all of Tuesday to finish up that quiz. Because you can see that these problems don't take very long, but there's a lot of different things that can happen, so I'll just kind of mix it up a little bit. We'll go over it on Wednesday. Okay, so you'll hand it in to me on Tuesday. I'll take a look. I'll give them back to you. We'll go over it on Wednesday. And then probably starting Wednesday, we'll do the second one, and that one will be for correctness. First one's just for effort and completion. Second one will be for correctness. Starting Wednesday, finish it Thursday. And then we'll see where that gets us on Friday. That's kind of my tentative plan for next week. I'll put all that up. All right, cool. So 6 is kind of just a weird one that I know we talked about really, really briefly at the end of class a couple days ago, maybe 2 or 3 days ago, about what to do when we've got whatever base we want. I'll just put an x, it can be whatever you want. And it's raised to a power that's a fraction. Right, so for example, like x to the, and I think I did this one, or at least something similar to this, x to the 2/3. Or x to the 3/2, or x to the 1/2, or x to the 5/7, or whatever it is. Yeah. And maybe this is exactly what I did. Maybe it's flipped, so maybe that's actually a good thing. But what happens with positive exponents are good. What happens with negative exponents, we've got to make the switch. If it's 0, it's just everything's gone. We just get a 1 left behind. So we just wanted to kind of fill in the empty space in between all of those whole numbers, and the fractions can do that. And so what we're going to look at is like each part separately. Okay, the top's going to do something, and the bottom's going to do something else. In general, the top of the fraction is going to be the power that you're going to raise that base to. Like so, in this case, this is going to have an x squared as part of it. And you see, I left a little space after the equal sign, because that thing that's on the bottom is going to do something else. Does anybody remember what the bottom part was? It's the root, yeah. So it's power over root. And so that 3 really means the cube root. And it's all like put together around whatever the x or y or a or b, whatever that is. Okay? And just like with negative exponents, we can't leave them like that. We can't leave fractional exponents. We have to make the switch. Okay? Oh, thank you. Right? When we write it like this is with rational exponents. Okay? This we call radical form, and that's what we like that. Because now I can just kind of deal with it separately. Oh, just take x, I'll square it, see what I get, and I'll take the cube root of that. And so we're always going to go this way. Okay? They're not going to make us go back from radical form to rational form as part of like a final answer, but I will to make sure you understand things in both directions. Okay, so while going this way is what we want to do, okay, what the reality is that I want you to get comfortable doing both. Okay, we'll actually work in both. So I'll give it to you with a rational exponent, and I'll say, hey, write these in radical form. And I'll give you something in radical form, and I'll say, hey, write this with a rational ratio fraction. It just means fraction. Write it with a fraction. And that's it. Like power over root really just means, okay, take x, raise it to that power, and then take whatever that root is and put it. And that's it. That's that last property, is being able to make the switch back. Let's sit down. That's it. Let's just try another one so we can kind of see what that looks like. A, because who cares what the letter is? A to the 5 halves. 5 over 2. And again, there's no like equal sign here to start. We're not solving anything. We're just trying to rewrite it in a way that we just like can wrap our heads around better. It just kind of makes more sense. And it also kind of breaks these apart too. Like 5 over 2 is like one number. I want to kind of break the 5 and the 2 apart separately, deal with them separately just to kind of make my life a little bit easier. Base doesn't change, it's still just A. Right? X was X, A is A. So what's the power that I should put right here in that exponent spot? 5. Cool. That takes care of the top. Top part's done. So what kind of root do we have then if there's a 2 on the bottom? So do I really need to put the 2 right here? So don't. Because the smallest root I can have is the square root. If it's just the first root, then nothing's happening. Like raise it to the first power, it doesn't do anything. Same thing with the root. With the first root, that's nothing. So we need at least a square root. And that's it. Just like all these properties, one step, and you're done. Let's go the other way just so we can get comfortable with it. The fourth root of m to the third. Rewrite this using rational exponents. Rational ratio fractions. Give me a fractional exponent. Well, what's the base? Like, what's the letter? M. Okay, cool. So I'll just start with that to give me a place to kind of like go up into the exponent for whatever I'm dealing with. When I've got both like this, I know I've got some kind of fraction. Hey, even if this was like a 1, like don't erase it, I'm just going to show you. Like if it was just that, it's still like a power of 1. And that's still going to give me some kind of fraction up there. Realistically, anything that has a root came from an exponent that was a fraction. Because if it's just a power, the root would be 1, like 5 over 1. This is 5. I don't need it. Right? But if you have a root, it came from a fraction. But we're doing this one, so let's do that. So what number should go on top of this fraction? Yeah, power. And on bottom?
4.
Done. There you go. Try these 2 just for practice, just to make sure you're good, because we talked through those. Try these 2, we'll call it a day. You don't have to submit anything, just kind of add them to your examples if you want. I don't know. E for Ethan. E to the 7/5. I don't know. Write that in radical form. And then the third root of C, nice, to the, give me a number, Chase.
7.
No, we already have a 7.
9.
9? No, because 9 over, no. Nope.
6.
Nope.
What do you
Nope.
want?
Stop picking multiples of 3. Thank you. 8 sounds good. 3, 6, 9.
Let me get much easier.
Well, the issue is like power over root. 9 over 3 is just 3, and I don't need to write it like that. This only really comes from that place where you just can't simplify. Right, 2/3, 5 over 2, 3 over 4, 7 over 5. I can't make a whole number out of those fractions. So it's only really reserved for the fractions that are still fractions or decimals when you plug them in. So give those two a shot, kind of go in both directions, and then I'm good. I'm done. Nice chill Friday for you guys. You guys have been working hard all week. I really appreciate that. Thanks. 8/3. Love it. Beautiful. I'll put up the answers here in a second so you can check them, but we've got a minute. Here they are. Oh. Camera can almost see it. Hold on. Go through to the e to the 7th, c to the 8/3. Done. 15 seconds or so. Maybe it's a minute and 15 seconds, so we'll see. Because this only says 123, so that.
It is only 120.
Yeah, we might have a minute. So hang out for that minute, and then you are off the 7th. Listen. Yeah. One more minute. Thanks, everybody. Yeah.
Peyton and I have world history.
This is my favorite song.
I was being sarcastic.
I know you.
My favorite
I'm so glad. I love teaching this class. So watching you guys just get it is like the best feeling.
Well, and it's so funny because this is the first math class I've had in high school that like just understood it.
First day I've ever had in math class.
It just like surprises me, like you guys are doing so well.
Well, and then,
And even if you're struggling a little bit, like you're working hard.
but then my 8th grade teacher was like, "Oh, you're never gonna succeed in that."
That's the spirit. Thanks to the pep talk coach.
That's what my mom
Like, I don't
said.
understand that. Why are you gonna get into teaching if you're just gonna bring kids down?
And my mom would go to him and say, she's gonna be taking high school, college algebra.
That's right.